Hello everyone, I am Revathi. I am working as assistant professor in SNS College of Technology in Department of Artificial Intelligence and Data Science. In this video, I will explain how heuristic techniques help databases execute SQL queries more efficiently using logical improvements rather than the hardware upgrades. Let's start with a quick thought. How often do you search for data and experience slow results? In today's data driven world, delaying queries have a real world impacts from life or death situations in hospitals to lost sales in e commerce. So, optimizing queries is not just about speed, about efficiency, cost, and reliability. Let's meet Ravi, a fintech database administrator. He manages transaction data for more than 2 million users. His problem, transaction confirmations are getting delayed because his SQL queries are inefficient. They cause full table scans and generate large intermediate results. Now, Ravi has a major challenge. He must improve query speed without adding new hardware or increasing costs. Let's empathize with Ravi's situation. He faces constant user complaints about slow fund transfers during peak hours. He is under pressure to fix performance quickly but has no option to buy faster servers. His goal is clear to make queries faster using smart logic instead of more powerful machines. Now let's define the real issue. Databases often execute poorly written SQL literally. That leads to full table scan instead of using indexes, unnecessary joins or nested subqueries, inefficient ordering and grouping operations. As data volumes keep increasing, hardware scaling becomes costly and limited. Therefore, optimization should happen at the logical level before query execution. To solve this, we apply heuristic optimization, a set of logical rules that transform a query into a more efficient version without changing its result. Let's look at the main heuristic rules one by one. First one is select early. Push selection conditions closer to the base tables. This reduces the number of rows early in the query process. Second one is project late. That means it performs projection after join so we don't lose data. Third one is reorder joins. Reorder joins so that smaller or more selective tables are processed first, minimizing intermediate results. Fourth one is avoid duplicates. Remove unnecessary or redundant operations such as repeated sorting or grouping. These transformations make the query plan more efficient and reduce execution costs significantly. Now let's see how these rules are applied. Originally, Ravi's query had multiple joins and applied filters only at the end. This cost a cost of around 1500 units. After applying heuristic optimization, the where conditions were moved closer to the base tables, joins were reordered based on the table size, and redundant sorting operations were removed. The result is the optimized of query execution cost dropped from 1500 units to 210 units, a massive improvement without any hardware changes. Heuristic optimization techniques are widely used across different domains in healthcare for retrieving patient records faster, in e commerce for generating real time product recommendations, and in smart cities for analyzing live traffic sensors data efficiently. So, query optimization is not just theoretical, it is practical necessity in every data-driven industry. We empathized with the real-world database administrator's problem, defined why queries become slow, ideated heuristic rules to improve logic, built a prototype plan showing performance gains, and discussed real-world applications in this video. Thank you.